Hello everyone, again, welcome to the revision channel. Now today I thought we might do chemistry. Topic 1 of chemistry, that is. It's just basically getting started off. Now, speaking of getting started off, let's start with the basics. Atoms. We should all know what atoms are. They are the things that basically make up everything. That's why you shouldn't trust them. Now, there are elements which basically have the same atomic number. There are isotopes which just have extra neutrons, and well, atoms join together to make compounds. You know, simple stuff here. However, there are mixtures. Unlike compounds, mixtures can be easily separated and all that. And there are several separation techniques which you should know for the AQA course. The first one I'm going to mention is chromatography. Now, chromatography is where you basically get a piece of paper. It should be rather absorbent paper to absorb water. And the way this experiment goes down is draw a line on a piece of paper, right? And that line will basically be where your baseline is. And you put the piece of paper horizontally in the bit of water. Now, before you do that, I should probably say you put an ink dot on where that line is. Now, once you've put the ink dot on, you have the line, you place the bit of paper in the water should be just up to the baseline, right? The water will travel up the paper as it soaks up, and then the ink should then separate into individual colours as the ink will, get carried by the water. The next one is filtration. Now this one's rather simple, it's just filtration paper, and let's say if you have sand and water, you would just then pour that mixture into the filtration paper. The water goes to the filtration paper, but the sand doesn't. Boom, clear water and sand, you've separated the two. Now, when separating soluble solids from a mixture, such as salt, for example, salt and water, you can't use something like filtration paper because the salt is being dissolved in the water. So, you want to use these separate techniques to get rid of the water and keep said salt. The first one is evaporation, for example. Evaporation, as you can probably guess, you just evaporate the water under a flame. You put the solution into a evaporation dish, heat up with like a Bunsen burner or a flame or whatever, and the water will then evaporate, leaving the salt behind. Anyway, as I was saying, crystallization is more like a calmer version of evaporation, because what you do is you basically you evaporate some of the solution to make it a more concentrated solution, and from there you just leave it on a windowsill or something like that with natural high temperature, so it's slightly warm, to naturally evaporate the water, so you don't end up ruining all the salt crystals, for example. And as the water evaporates naturally, the salt crystals are left behind, similar to evaporation, but it does take a bit of a long. It is a bit of a longer process. Distillation. Now, this is a technique where you use you basically heat up, let's say, two liquids in a flask, and you heat up to a point where it reaches the boiling point of one of the liquids and not the other, and then one of those liquids will evaporate, going into a tube, which will then condense that evaporated liquid into a separate flask, and then you have the two liquids separated. I'll put up a picture of the apparatus you use about now. Fractional distillation is basically normal distillation, but you do it on a bigger process. So instead of just separating two liquids, you can be separating multiple liquids. So like, you would then work up a temperature gradient to then separate those different liquids. So if you had three liquids and they each had different boiling points, you would then use the boiling point of one, do that, separate that, the boiling point of another, do that, separate that, then you have the three separate liquids. And you could go up to loads of different liquids. In fact, in things like crude oil, they use fractional distillation in a distillery or something along those lines, to then get out the different liquids they need, such as diesel and petrol and all that stuff. Anyway, moving completely off topic, the history of the atom next, because that's relevant to chemistry. Now, John Dalton, at the start of the 19th century, he described the atom as a solid sphere. Then, in 1897, J.J. Thomson kind of elaborated on that with the plum pudding model, where he said that there were small little things of a negative charge in an area of positive charge. He coined this the plum pudding model, as I said, because what we now call electrons were basically the plums in a plum pudding. A plum pudding is a spherical pudding with plums in it. You can probably get that from context. Moving on from the plum pudding model, we have Rutherford and his alpha particle scattering experiment. In 1909, Rutherford basically grabbed a bunch of alpha particles, slammed them into a thin piece of gold. Now, when I say thin, it's not like foil thin, it was like atoms thin. And his idea was that if the plum pudding model was true, you would see these alpha particles just going through. Maybe there were a few changes, but mainly just going straight through this really, really thin gold sheet of paper. Now, when he saw that there were loads of reflections, or more than he thought, and there were loads of kind of changes in the alpha particle's direction when he shot it through this gold foil, he then thought the plum pudding model must not be an accurate idea. He then came up with the nuclear model, which Niels Bohr then worked on to create the... It's still called the nuclear model, but it's a more accurate version of what Rutherford came up with, and that's basically the atom we know and love today, with the whole circle and the rings around it and all that. The alpha particle scattering experiment is actually quite important in the history of the atom, because it's where we changed from the plum pudding model to the nuclear model, because we could see how the alpha particles changed in direction due to the charge, and how it bounced off again due to the charge, and hitting the nucleus, and all that stuff. Anyway, moving on to something else historical, the history of the periodic table. Now, you know, early 1800s, the way we would organise elements would just be, you know, their properties and probably their atomic mass, and that's about it. We didn't know all these different things about electrons and protons and all that stuff, which we do now. However, in 1869, Dmitri Mendeleev decided to create his periodic table. Now, with this periodic table, he left gaps. Now, this is the important bit. He left gaps where he couldn't fit anything else. There were gaps all over his periodic table. Now, that's not a bad thing. It's because in the future, when we discovered more elements, we could then fill in those gaps. And, well, that's what happened. Right, now, on the topic of the periodic table, the modern periodic table, I think it's worth mentioning that the alkali metals, group 1, that's the metals on the far left of the element, far left of the periodic table, its properties are that as you go down the list, it gets more reactive. So francium, I think, is one of the most reactive alkali metals in that list. Group 7 halogens get less reactive as you go down the list, and, well, noble gases are just not reactive at all. That's group A on the far right. I think it's just worth mentioning those, because those are basically generic properties you can find out when you're just looking at the periodic table. Now, I hope you learned something from this video. I hope you can take something away. I hope you can use it in your exam and all that lovely stuff. This was actually topic 1 of chemistry. In fact, I covered most of the important stuff. Some of the stuff I didn't cover was just because it's really simple stuff like atomic structure and all that stuff. As usual, if you want me to cover anything, then anything that I've missed, I will happily do it. If you want to see my future videos, feel free to just subscribe. And if you enjoyed this video and learned something, I suggest leaving it a like, because it helps promote the video so that others can learn what you learned. It's worth mentioning that I was thinking of doing history as a topic as well, because I know loads of people take history. I will be doing the courses that I'm doing, which is medicine through time, Cold War, Germany, and the other one, Elizabethan. So if you're interested in those, then I will do those as well. It's just information stuff. Anyway, goodbye.